This is the Chapter 8 test review. I'm going to go through several slides here, and it's going to take a little while. So for this, I'm going to put all the topics in purple on the top of each slide. So if you feel like you know how to do one, or if you don't want to, or if you want to skip around to different ones, you can just kind of move through this and figure out whatever the topic is going to be. Also, when you're going through, pause the video here at certain times so that you can try the problems. So I'm going to give you a problem. I'm going to stop talking for a couple of seconds. During that time, then pause it so you can attempt the problem. If you don't know what to do, that means you probably need some more help with that problem. So then after you play it, I will go through and I will explain how to do each step. And then from there, you can hopefully check your answer. And if you were not correct, maybe you need to attempt a couple more problems that are similar to that. So the first thing we're going to take a look at are sequences. So I have two different sequences. What I want you to do first of all is see if you can write the first 4 terms of each sequence and figure out if the sequences are arithmetic, geometric, or neither. So you can pause it now. Okay, if I want to write the first 4 terms, so what I'm going to do here, if I want to do term 1, that means I'm putting a 1 in for n. Term 1 is going to be 3 times 1 plus 1. So term 1 would be 4. Term 2 would be 3 times 2 plus 1, which is going to be 6 plus 1, or 7. And I can keep going from there. Another thing I can do to figure these out is once I establish this is my 0 term and it's growing by 3, I can then figure out, well, if it starts at 1 and it's growing by 3, that means term 1 is 4. And if it's growing by 3, term 2 is 7. And it's growing by 3, and it's growing by 3. So a couple different ways that you could figure that out. Those are the first 4 terms. And this is going to be arithmetic. Taking a look at the red problem. If you have not already tried it, then pause it. Okay, again, doing the first 4 terms. If I wanted to do term 1, again, I would put 1 in for n. This time, n is your exponent. So I would have 4 times 3 to the first. That is going to be 12. Term 2 is 4 times 3 squared. Order of operations, I need to square that first. That is 9. 9 times 4 is 36. I could continue with that method. Another thing that I could do is, again, knowing how this problem is set up, that is my 0 term. That is my multiplier. So a 0 term of 4, multiplier of 3, term number 1 is multiplying those together to get 12. My multiplier is 3, so I take 12 times 3. And then I take 36 times 3. And then I take 108 times 3. And those are my first 4 terms. This is geometric because there is a constant multiplier. Anytime you have a constant multiplier, that is a geometric sequence. The next topic, factoring and zero product property. The first problem I'm going to look at is this one. So I want you to solve this using factoring and zero product property. Please pause it now. Okay. So to factor, I'm going to make my generic rectangle. My first term of 3x squared is going to go in the bottom left. My last term of negative 4 is going to go top right. Once I have that, I now need to go to my diamond problem. Multiplying these two together go up top, so I get a negative 12x squared. My middle term of negative 11x goes in the bottom. And what two things add to negative 11x but multiply to negative 12x squared? That is going to be a negative 12x and a positive 1x. Now what I'm going to do is take a look at these and what is my greatest common factor? What can I divide out of both of those? And that would be x. If I think of my greatest common factor here, that would be a 3x. And x times 3x gives me 3x squared, so that works out. X times 1 gives me that one. And 3x times 4, negative 4, gives me my negative 12x. So now my factors are x minus 4, 3x plus 1. That is the same as this. It's just written in a different form. So it still equals 0. This is where the zero product property then comes in. Once I've rewritten in factored form, I'm going to go through, give myself a little bit of room here, and I'm now going to go through and use my zero product property. The zero product property is taking each factor and setting it equal to 0. Because if two things multiply together to equal 0, one of them has to be 0. So I have x minus 4 equals 0. Or I have 3x plus 1 equals 0. Those are my two problems. For the top one, I'm going to add 4. And I get x equals 4. That is one solution. The other one, I'm going to subtract the 1. So 3x equals a negative 1. And when I divide by 3, I get x equals a negative 1/3. So my two solutions are 4 and a negative 1/3. I'm going to let you practice this again with another problem. So please pause it now. Okay, just like last time, I'm going to start off with a generic rectangle. X squared and 18. My diamond problem, 18x squared, a negative 9x. If they multiply together to be a positive, but add to be a negative, that means both factors have to be negative. So in this case, it's negative 6x and negative 3x. Greatest common factor out of there is an x. X times x gives me x squared. X times negative 3 gives me negative 3x. And x times negative 6 gives me negative 6x. Again, negative 6 and negative 3 adds up to that number, or multiplies, to that number. So that works out as my factors. So again, now rewriting this problem so I can use zero product property gives me x minus 6 times x minus 3 equals 0. So using my zero product property, either x minus 6 equals 0 or x minus 3 equals 0. Adding the 6, I get x equals 6 as one solution. And adding the 3, I get x equals 3 as my second solution. Those are my two x-intercepts. The next topic, write this in standard form and state the x and y intercepts. So go ahead and pause that and see if you can answer that question. All right, first thing I'm going to do here is I'm going to do my x-intercepts first because I don't need to do much extra work. It's already in factored form. If I want my x-intercepts, that means the y value is 0. So now I just do my zero product property. I have 4x minus 3 equals 0, and I have x plus 5 equals 0. So very similar to the last problem. I add 3, and 4x equals 3. When I divide by 4, I get x to equal 3/4. There's one solution. From the second factor, I subtract 5, and x equals a negative 5. Those are my two solutions for this problem, for my x-intercepts. For the y-intercept, I'm going to want to write it in standard form first. So if I get rid of some of this information here, I'm just going to move this over. Those are my x-intercepts. To write it in standard form, I'm going to make a generic rectangle again. I'm given the product. This is the product. I want to find the sum. 4x minus 3 and x plus 5. Filling in these over here. Combining my like terms right here gives me 17 x's. So in standard form, this is y equals 4x squared plus 17x minus 15. That is standard form. And my y-intercept now is negative 15. So I've written in standard form here in purple. I've solved for my x-intercepts, and I solved for the y-intercept. Next topic. With this quadratic, graph it, and doing that, writing your x-intercepts, your y-intercept, and your vertex. Go ahead and pause that. All right, so the first thing I want to take a look at here is I know the y-intercept is right here at 3. So if I'm going to graph that, I can right away put my y-intercept at 3. But I need to solve for my x-intercepts and my vertex as well. So before I go through and finish up that graph, there's a couple things I can do. So what we've been working on in this chapter is going through and finding our x-intercepts by factoring in zero product property. So I can do that right now. I can just make y 0, x squared minus 4x plus 3, and I can factor that. So if you remember, or if you're not quite sure on factoring, make sure you're going back and looking at factoring on these problems here. Okay. This factors into x minus 3 times x minus 1. My x-intercepts then, using zero product property, are 3 and 1. So 3, technically 3, 0, if you want to write it as a coordinate point, and 1, 0. The y-intercept would be 0, 3. Now, another thing I can do is if I'm looking at a graph, I have my y-intercept here. My x-intercepts are at 1 and 3. My line of symmetry is halfway between my intercepts. That line of symmetry is x equals 2. So I can put 2 into this equation for x. So when I do that, I will get 2 squared minus 4 times 2 plus 3, which gives me 4 minus 8 plus 3, which is negative 1. So my vertex is at 2, negative 1. Once I know that, and my line of symmetry, this point right here should have a corresponding point right here because it's 2 units away from that line of symmetry. And now I can draw my graph. Another way I could do this, if we don't have all this information, what we've been doing in homework lesson problems for a while, and we've also been doing this since about chapter 1 or 2, is we can always make a table. So 0, 1, 2, 3, I can even test some negative values of negative 1 and so on. So now if I put 0 into my x values here, I get 3. When I put in 1, I will get 1 squared is 1 minus 4 times 1 plus 3. That ends up giving me 0. When I put 2 in, I get 2 squared is 4 minus 8 plus 3. And I'm going to get negative 1. When I put 3 in, I get 3 squared is 9 minus 4 times 3 plus 3. That is also 0. You may notice right now, these are the same. That means this one should be my vertex. If I did want to try some negative values, I just wanted to put this on here, just to remind you that if I put negative 1 in and I square it, that is a positive 1. Negative 1 times 4 is positive 4 plus 3, so my negative 1 value would be 8. So now if I would go through and graph all of those, I would have my y-intercept would be here, my x-intercept's there. We found my vertex right there. We knew this point because of that one. And if I did take a look at the other ones, any other negative values, at negative 1, it was up here at 8, which means this should be at 8 over here as well. And there would be my parabola. So factoring zero product property is what we worked on this chapter. Averaging your intercepts for your vertex, we worked on this chapter, but we have made tables for quite a while. The next problem we're going to work on here, factoring completely. Notice this is not an equation. There is no equals, which means we are not going to solve it. We just want to factor completely. Go ahead and pause and try that. Okay, one thing I want to look at first is that all of these coefficients, all the numbers, have something common to them. So I can divide each of them by 4. So if I divide a 4 out, I have x squared plus 5x plus 6. That is the first thing I want to do when I'm factoring completely. You want to make sure that if I can factor something out, I take that out first. My next step is to factor what is left. So that, I'm going to make my generic rectangle and my diamond problem. That's going to be a 3x and a 2x. Taking out my greatest common factors, I get my factors to be 4 times x plus 3 times x plus 2. Trying another one of these problems. Factor completely. Pause it. Okay. Hopefully you've noticed that there is a 3 that you can take out of both terms. When I do that, I get 3 times, in parentheses, x squared minus 4. So the question is, can I factor this? And the answer is yes. X squared minus 4 is a difference of squares. So if you remember the shortcut, it is 3 times x plus 2 times x minus 2. If you do not remember the shortcut, we can go through and do our generic rectangle and diamond problem. X squared and negative 4. That's a negative 4x squared, but my middle term and my x term is a 0. That gives me 2x and negative 2x. So again, x, 2, and negative 2, and that's where these factors came from. But again, factoring it completely means I have all of these written down as my final answer. And one last one. Okay, hopefully you have solved it now. There is a common term to both of these now, not just a number, but also with x's. So the largest number I can take out of 10 and 4 is a 2. But since this is an x cubed and here is an x, I can take an x out of both terms. If I divide this by 2x, I have left 5x squared. Because if I redistribute this, I need to make sure that this is what I get as my result. And then plus, when I take 2x times whatever is here, I get 4x as my result. So that has to be a 2. So that has now been factored completely. This cannot be factored any further, so the problem is done. I hope that was helpful. Hopefully you do well on your test. Let me know if you have any questions.